Welcome back, students taking Math for Business and Finance and Math Applications. We're working on the Chapter 14 word problems, the odd number problems. And before we get started, I just want to say that I kind of like struggled a little bit with the theory portion of this particular chapter, for the simple reason that it basically is what you've learned in previous chapters with just a few little idiosyncrasies. And I had said that in doing the theory, the best way to get it would be to actually work through the drill problems and the word problems. And you'll see that the processes are basically the same, with the exception of a little idiosyncrasy here and there, like, for example, a monthly payment or whatever have you. So what you're going to see here in working through these problems, it will be, again, pretty repetitive. It's not like something new repetitive. It's repetitive from the previous chapters, but you're going to have to identify those little idiosyncrasies. Also, too, I'm not going to be using the tables, okay? So I'm going to be just quoting factors. It's up to you to be looking those up, either from the tables in the textbook or from the Business Math Handbook. For this set of videos, I'm not going to include the tables. I'm just going to reference things. I mean, I'll tell you what the percentages are and the number of periods or payments, but you're going to have to cross-reference. And I suggest that you do that before I actually give you the number, so that this way you're finding it for yourself. And then if I give you a different number, and you're wrong, you can figure out why you're wrong. If I give you the number and then you have a tendency to look at the table, you're going to try to be zeroing in on, let's say the number is 28.73. You're going to try to zero in on 28.73 and, sort of then cross-reference the percentage in the payment. And that's going about it backwards. And when you don't know what the factor is supposed to be, you're going to have to figure it out anyway. So pause, look up the factor, and then double check with whatever I give you. Okay. Now, the last thing here is, let me move on to the next slide here. Okay. For word problem 14-9, this is going to take up the remainder of this video. I'm going to spend the rest of this video on this one problem. What's going to happen here is I'm going to work through this particular problem in one fashion. Okay. And then anyone who is doing math applications, so that's like vet tech students, medical students, if you want, you can just stop the video at that point in time and move on to the next video. But what's going to happen here is I'm going to show something that's pretty interesting for accountants, anyone in the accounting curriculum. This is I would not say it's an absolute must-watch, but it is sit back and watch this video, because this pertains to a level of understanding that you're going to need as you move forward in your accounting curriculum. And for those who have an interest, even if you are in vet tech or medical, if you're interested in seeing an idiosyncrasy, continue to watch. People who take other business curriculums, it will help to watch the last half of this video, so that you have a better understanding as to why you're learning what you're learning, and certain distinctions that need to be made, because you're going to be out in the real world and you're going to be a professional. So with that said, let me work through this problem and you'll see what I mean. Okay. All right. So it says here, let me get my pen. It says here, for the best terms on a loan or credit card, you will need a credit score above 700. To achieve this, start establishing credit now. Pay all of your bills on time. In addition, use only 1/3 of your available credit limit and pay off your revolving balances each month. Okay, all of that basically says is you should just maintain good credit. So all that is really not pertinent to this problem at all. RJ Johnson has excellent credit. She wants to purchase a piece of equipment for her business, was offered a 6%, 60 months for the $55,000 unit. So it's asking us, what is her monthly payment by formula? So let me write up here in the corner. All right. As you recall, for the monthly payment, we take our finance charge plus the amount financed, and then we divide it by the number of payments, and that will equal our monthly payment. Okay. Now, here's the thing. I mean, we know what our amount financed is. That's this 55,000, and we know what the number of payments is. That's 60 months. But we don't know what the finance charge is. We don't know what the interest is. Okay, so we have to figure out how much interest. And if you recall from the previous chapters, interest is equal to principal times rate times time. Okay, so our principal is 55,000. Our rate is 6%. And our time is 60 months. But notice that that's months, okay? Our 6% is an annual rate. And when we're looking at this formula, what do we have here in the numerator? You know, we have a total amount because we're having the deferred purchase price. We're having that, you know, what it is you're going to end up completely paying for. And we're dividing that by the number of payments in order to get the monthly payment amount. Okay, so by having 60 months here, and this at 6%, we really don't want 60 months. You know, 60 months translates into 5 years, which is an annual number. Okay, so we're going to, you know, divide this 60 by 12 and get 5 years. Okay, and now we can do the math in order to find what our interest is, and that ends up being $16,500. So when we take the 16,500 and we plug that into our formula, okay, and our amount financed is 55,000, and then we're going to divide that by, now the number of payments is monthly. Remember, this is a total amount. It's, you know, it's like saying, you know, I have, you know, 10 pizzas and I have, you know, 10 slices in each pizza. You know, how many slices do we have all together? 100. Well, we're doing the same exact thing. We're taking and saying, we have this total amount that we're, you know, actually have to pay back, and we want to know how many, you know, how much it is on a monthly basis. So we divide by that many months in order to know how much to pay back each month. So in the denominator, we end up dividing by 60. Okay. So if we take the 16,500 plus the 55,000 and we divide it by 60, let me do 16,500. 55,000 times 6 times 5 is equal to plus 55,000 divided by 60. We find that our monthly payment is $1,191.66, I'm rounding to 67 cents. Okay, so that seems to be relatively easy and relatively straightforward, and that's quote unquote doing it by the formula. Okay, so with that, anyone who wants to stop watching the video, you know, go ahead and stop watching the video, because that problem is worked out, and that this answer of $1,191.67, you know, is acceptable. But for anybody else who has the curiosity, or like I said, if you're definitely in the accounting curriculum, and it's also helpful for those in the business curriculum, what you should do right now is you should pause the video and copy all of that down and make sure you have it, because when I come back, I'm going to end up erasing it. Okay, so pause the video and I'll be right back. Okay, so for those who have paused, who have continued on, what I'm going to do here is in the upper right hand corner, I'm going to write down this $1,191.67. Okay, and that's our monthly payment as we saw it all figured out. But notice now I'm going to erase all of this information. Okay. The wonderful world of digital tablets. Okay. All right, now I'm going to segue a little bit here. Okay, um, you may or may not have heard the concept EPS, earnings per share. Okay, that's short for earnings per share. Okay, and when we convert that, the per is basically division. So what we have here is earnings divided by shares. Okay? And earnings are basically, your net income. And your shares on a simplistic level are your shares in stock, okay, whether it's common stock and preferred stock or whatever have you, okay, but they're the number of shares. Okay, so when you first start your education, and remember, we're talking about concept here, all right? When you first start your education as a professional in your first semesters, in your freshman year, your first semesters, I mean, you've heard of this analogy. It's like an onion, you peel away a level and it goes down to another level, and you peel away another level and it goes down to another, and so on and so forth. And I like using this earnings per share as an example, because when you're here over in your first semester and you're first getting started, or in your freshman year, you're given things as an overview, okay, from a higher level, right? Now, your calculation for the earnings per share might come out to 0.07 cents. And, because all we're doing is taking earnings and dividing it by shares. But as we gain more sophistication in our education, in other words, as you move from your first semester to the second semester to your sophomore year to your junior year, you gain a higher level of understanding and a deeper level of commitment to the concepts involved, so that if you're in the accounting curriculum, the earnings per share calculation, okay, actually when you do intermediate accounting, and you'll have it in intermediate accounting too, the earnings per share is no longer just simply earnings divided by shares. Actually, the calculation ends up being 3 blackboards long. Okay. Now, I don't say that to scare you. I just want you to realize that the mathematical calculation, you can start out on a simplistic level here or a more complicated level on here. And when you do the more complicated level, maybe this 0.07 cents would end up being more like 0.89 cents. Okay, which is right, which is wrong? Well, depends upon your level of education, okay, or depends upon what you're looking for. And students will make an argument, well, if I'm here in intermediate accounting and you give me this answer, that's wrong, all right, because you're not using the level of education and sophistication that you need. Okay, a student will go, well, and they'll say, well, I put 0.067 even if they are just doing earnings per share. Okay, and that's wrong, because it's supposed to be 0.07. But the whole idea here is that as we progress, we gain more levels of sophistication, and we're able to gain more accurate numbers. So what does that have to do with this problem? All right, let me erase all of this. I hope I haven't lost you just yet. And I know this video is getting pretty long, but as you recall, when we were talking about the time value of money from previous chapters, okay, present value and future value, as you recall, I had said that 200 years ago, when all you had was a pencil and paper, okay, they had to do the math by hand, and they did all the calculations. So if you had a 30-year mortgage, right, you want to know the monthly payment, they had to do 360 calculations, right? Then the mathematicians came along, and they went and they worked on the problem. They came up with a formula, all right, formulas. And the formulas were very, very specific. They were accurate, okay? And if you had the math knowledge, the algebra knowledge, those 360 calculations now might have been worked down to about 15 calculations, okay? And, became more efficient and more accurate, right? But the mathematicians also found that there was a correlation between the interest and the number of periods or the payments, okay? And so they created the tables, okay, which on the tables they had factors. And you all know this from the previous chapters, so that now instead of doing 15 calculations, if we use the factors, we only would have 2 or 3 calculations, okay? And of course, we're a lot more efficient in that we get the work done more quickly, and we'd be a lot more accurate because we'd have less of an opportunity to make a mistake. However, the accuracy, that in doing it using the tables, we give up a certain amount of accuracy. Okay. All right, and with that accuracy, now if we had, we can have a number, I'm just going to make something up here. If we use the formulas, maybe we had $318.79 using the formulas, okay? But if we use the tables, we might have had $318 and say 93 cents using the tables, and that's due to rounding, okay? In the tables, the factors generally go out 4 places, right? Okay, and but they could go on a lot more based upon the formula, and which would bring us more and more closer to the more accurate number of the formula, right? But for all intents and purposes, who's gonna, we're not gonna worry about, the few cents. Now, when you're talking about millions of dollars and hundreds of millions of dollars, yeah, you're using a computer, you're using a calculator that has the formula built right into it and gives you the most accurate number, okay? So with that said, and here's where all of the rub comes in, okay? It says here, we do this by the formula. And we did, the very, very simple formula, the finance charge plus the amount financed over the number of payments. And we had interest is equal to principal times rate times time, and we ended up with that number. Okay. The reality is that we were already presented a formula previously in one of our other chapters, okay? And that formula for the payment, okay, because we're looking for a monthly payment, that formula for the payment is, interest times the amount over the, let me get this right here, all right, 1 minus 1 plus the interest raised to the minus nth power. Okay. Now, if that formula can go back, and I forget which chapter it's in. Okay. That's the actual formula for the payment. Okay. Now, the reason why I'm bringing this up is because you saw, if it says by formula and you're using these here simplified formulas, are they accurate? Okay. Well, here is the actual payment formula in and of itself. So if we try to work through this, okay, so what we're looking at here is we're looking at the interest per period, okay, and the interest per period, if it's 6%, okay, and we divide it by 12, okay, that gives us 0.5%, okay. So 6% divided by 12 is 0.5 as a percent, and in a decimal form that ends up being decimal 0.005. So if we plug in 0.005, and then we plug in the amount, the principal amount of 55,000 here in the numerator, and then when we look in the denominator, we have 1 minus 1 plus, again, the 0.005 for the interest, and it's raised to the negative 60th power, okay? Now, that's what should be in the denominator as a mathematical calculation. Now, I'm not going to do the math by hand, okay? It gets to be really, really complicated. It can be done by hand, but it's a lot easier to deal with this here negative 60th power using a calculator, but of course you have to know how to use your calculator and how to be able to use not only exponentiation but negative exponentiation in your calculator. So with that said, suffice it to say that when I end up doing this math, okay, in my numerator I'm going to get 275, okay, and in my denominator I'm going to end up with 1 minus, and so when I do what's in the parentheses here, remember that's 1 plus 0.005, so that's 1.005 raised to the negative 60th power. Well, that figure ends up being 0.74137, okay? And so when we take and subtract that, we have 275 over 0.25863, and when we divide the 275 by the 0.25863, what we end up with is a monthly payment of $1,063.30. Okay? Now, that number is definitely not that number. And that's the idiosyncrasy. And that's what you've been watching and trying, I'm trying to get you to wrap your mind around here. In that, if you did this in a calculator or a computer, okay, you're going to end up with this here figure of $1,063.30, and that's an accurate number, okay? But in lieu of that, when you're just doing the basic math, okay, and you just use these more simplistic formulas, you're going to end up with that figure. I mean, that, and you're talking about a $130 difference in a monthly payment there, okay? So which is more accurate? Well, that's why the banks will use the computers all the time. And as accountants, all right, now this is for those that are going into any kind of financial field or whatever have you, you're going to end up using the payments, and you're going to be, you're not going to be able to, you don't use the normal earnings per share on a simplistic level formula. Okay, as you progress in your education, you're going to be expected to use the more complicated formulas and be more accurate. So even though you will have tables in your intermediate accounting course where you can pull down the factors, the reality is in the workplace you're not gonna rely upon tables anymore. Okay, now for math for business and finance or math applications, yeah, we're using the factors because we're in a learning process. But out in the real world, realize that if you're going to be in the business or financial field, you're going to be expected to be using those formulas and understanding them. So math for business and finance is on a simplistic level. And yes, you were just introduced to those formulas, and yes, you're not expected to use them. Yes, when you get to intermediate accounting, you're going to have tables, but you're also going to start using those formulas a lot more. And when you get out into the real world, you're only going to be using those formulas. All right. And you're not going to be taking the shortcuts. Yeah, if you're talking to a client and you want to do a quick down and dirty, you can do the earnings, the simplistic earnings per share, or you can do simple here, but you're going to warn your client that, that there's going to be some variation there. So I hope that a little bit of extra 10, 15 minutes of time here trying to show you the levels of sophistication in your education, where it comes from, and why it's required will help you better understand what you need to be doing in the workplace and why you're actually going through all of this. Okay, and I just happen to find that this problem, lent itself very well to that situation, and that's why I spent the time on it. Okay, so if you have any questions, oh, by the way, this particular problem, there are some students who will actually, they will actually, do the problem this way. Let me get it. No, they'll actually do the problem this way and get this answer, but there will also be students who come up with this answer. All right. because they are using this payment formula. All right, and that's kind of like also why I've spent the time here, is because that's been an issue that's been addressed enough to where by students, in that we've made notes as far as instructors are concerned in order to be able to explain it to students, but now I'm putting that information here in the video for you. Okay, so with that said, I'm done with problem 14-9, and thanks for listening to me. Hope you got something out of that, and we'll move on to problem 14-11 in the next video. Okay, see you then.